Come here.
All right, guys. I think I'm up and running.
Are you coming or no?
Should be up and running here. So go ahead and ask questions, and I can go from there. I'm like really washed out today. I don't know why. No, I have 3 concurrent viewers right now. Yeah. So you and 1 person. Oh, okay. Well then, I am going to see if I can fix my coloring while it's actually streaming. Let's see. Slide this over here so I can see it better. Now I just look a little red. Now I'm red, but I got rid of the reflection. Is that what I actually look like?
More towards you, but yeah, pretty much.
Huh. Didn't know that.
I mean, it's a little better, like, not as red.
So maybe add a little bit of blue. It's weird as my chat hasn't even popped up because I typed something in there. Not on my stream. So maybe the hue shift. That doesn't look bad. I'll figure it out later. I have to do a little research into it. Wondering why. Oh, I know, because I have my chat turned off. There it is. Oh, I have somebody that did you like me? Was that like you? Somebody's on here. I have 4 people watching. Oh. So, no math questions. So I'm just going to go find some random math problems to work since I'm here doing this. So let's see. Where are my books? Oh, I have to plug in my Well, now. Huh. All my books are on the hard drive and I have all my USBs being used. Should have thought that through. What do you mean, my man? Oh, he quit working a couple years ago. The actual USB extender and all that I have is at the school where I can't get to it. I don't feel like buying another one just for this. Yeah. Hey, though, I did get rid of the reflection. You see the reflection on the stream?
No. Just a little like a...
But not much at all. And I don't look horribly awful. So they changed it where I'm not doing Algebra 2 to take the burden off and spread it to other people. So all I have to do is do geometry. So I'll get that knocked out. I'll take a look at the packet that was sent. Work some problems in that. Oh, that's what I can do. Is I can work some of those problems since it's already there.
Right, so yesterday.
Hold on, let me pull it up.
But you got some printed.
No, these are the problems for... I don't know, maybe I can. A lot of these are so low level though. I know what I'll do. I'm going to explain Dr. Loes' method. Nice. That's exactly what I'm going to do. All right, so since nobody's asking questions, I'm just going to work a problem. Are you talking about the geometry packet or the Algebra 2 packet? I haven't read through the whole packet. I put together the math problems on here. I haven't read through it. I actually just went and picked it up this morning just to kind of see what you guys are seeing. Once I get a chance to read through it, I could probably respond back and kind of, ask questions myself, clarifying questions, and get that information out to you if you let me know. All right, so I'm going to go ahead and start with, I'm going to solve a quadratic by using Dr. Loes' method. This is a brand new method of solving quadratic equations. For many, many years, there's been some pretty standard ways of solving a quadratic equation. A quadratic equation has a form of ax squared plus bx plus c when it equals 0. And there's different methods to actually solve this whenever a, b, and c are something. Oh yeah, see, that's my bad because I already had that made. That was originally going to be day 6 of something that I was going to be doing, and I just didn't change the title of it. So day 3, day 4, and day 5, I had something else planned that we were doing in class. Like I had one day was for a test, so I wasn't going to give a test on this. Another thing was like a little quiz and stuff like that. So that was just how I labeled things. That's my fault on being confusing. So I would just do it in the sequential order of the numbers, even though they're not sequential. So I would do like 1, 2, 3, 6, I think is what I put it in there. So there is nothing in between. It's all like tests and other assessments that I had built in. So one method was to complete the square. That's always the fun one to do. Another method is if our b was 0, when b equals 0, we could do the square root method. So we have complete the square. When b is 0, we could do the square root method. Of course, we could always factor. We could factor and use the zero product property. And then the fourth one, which is the fail-all that everybody knows, that it was just kind of drilled into you, is the quadratic formula. And with the quadratic formula, that is the negative b plus or minus the square root of b squared minus 4ac all over 2a. This is actually derived from this first method, the complete the square method. And this has been the way for my entire life that solving quadratics have been done. Now, there's other ways that you could approximate by using Newton's method with his calculus, and another way that you can actually use bisection method, which is an approximation tool that you can use with algebra. But Dr. Loes, he is a professor out of Carnegie Mellon, and he was researching, and I'm taking this from an article I read, he was researching on how to explain to junior high kids how to actually solve a quadratic equation, because it gets confusing. There's a lot of different options out there, and some of these are not very intuitive if you're not a math person. And he actually derived or came up with a new sequence of steps to actually solve this problem. I've read through his proof. The proof where I found, it was sent to me by my wife, April. When I saw the message from her saying it was new, I was like, yeah, no, nothing ever really comes new out of this type of math. But it really was. I sat down and read his proof. I can't say what I actually said to myself when I realized it actually worked. So I'm going to do a pretty basic one here. This could be solved by factoring. But I'm going to solve a quadratic to kind of illustrate how this actually works. All right, so I'm going to start out simple. I would ask you to solve something like x squared plus 15x plus 44 equals 0. This is on that day 6 algebra 2 that you were having your hand saying it was confusing. This is actually number 2 on that packet, in that packet. So to solve this, we could factor this. We could do a times c, doing the AC method of factoring. We could do the quadratic formula. We can even complete the square, but those are old. Those are boring. Let's see the brand new thing that's less than a year old on how to solve a quadratic. Is based on 2 ideas. You need to have a sum. Your sum is actually going to be negative b. Now keep in mind, we have that form ax squared plus bx plus c. So your a is the number in front, this right here is your b, and this right here is your c. So my sum is negative b. So if I look at my b, it's 15. So I need to do the negative. So my sum is going to be negative 15. All right. Now, then I'm going to have a product, and this product is just your c. It's your c, which is going to be 44. So from this whole idea, I'm going to be able to solve this quadratic and not factor, not do the quadratic formula, not complete the square. This whole process is you're going to have a random number. You're going to take half of your sum. So I'm going to do, let's see, half of negative 15 is going to be negative 15 divided by 2. And I'm going to add some random number to it. And then I'm going to do negative 15 over 2. And I want to subtract some random number to it. And when I was thinking about this, why this could work is because I was really, as I was read through his proof, it was brilliant. It was written by a brilliant math person. But I was trying to figure out, why does this actually work? And the only thing I could think of is that we have the axis of symmetry that splits a parabola down the middle. So if I knew where that is, I could find 2 points that are equal distance. And that's what this is happening right here, is I'm trying to find 2 points that are equal distance. But I need to find this u. And of course, then here, I'm just going to set it equal to my product because I'm multiplying these 2 together. From here, I just simply FOIL this. which would end up giving me, well, 15 and 15 is 225, so I have 225 over 4 minus u squared equals 44. Beautiful. And from here, I'm just going to solve for u. Not terribly bad. I'm going to subtract 225 over 4, so I have negative u squared equals 44 minus 225 over 4. Real quick, some scratch work. I'm going to do 4 times 44, which should be 176. Let me double check. Yeah, 176. The reason why I'm doing that is to get a common denominator. So I'm going to do minus u squared equals 176 over 44 minus 225 over 225. And that gives me a negative 49. So now I have negative u squared equals a negative 49. Divide both sides by a negative or just drop it. So I'll get u squared equals 49. Take the square root of it. Normally I do the plus or minus for the square root, but the next step is going to take care of that. So just take the square root of whatever this number is. U is going to be the square root of 49. Last time I checked, that is 7. So we're not done yet. So now that we know what u is, I can actually find my answers. I just plug them back in here. So I'm going to do negative 15 over 2 plus 7. That's going to be one of my answers. And I'm going to do negative 15 over 2 minus 7. That's going to be my other answer. All right, so when we do this, this ends up being, let's see, common denominator, negative 15 over 2 plus 14 over 2, which gives me a negative 1/2. So there's one answer. And then over here, same thing, negative 15 over 2 minus 14 over 2, which will give me negative 29 over 2. And there's your answer. So your answers would be, x would be negative 1/2 and negative 29 halves. Now, hopefully I did this right because this is live, and if not, then I'm sure somebody in the comments will point out my math mistake. So I'm going to check it real quick. I'm just going to do a little cheat. X squared plus 15x plus 44. I'm going to go to my table. I need to do the ask function. My independent I want to ask. Go back to my table. I got negative 0.5. It is not right. What did I do wrong? All right, let's proofread. Hate this. Proofread. All right, so my sum is half of b. Negative 15 over 2, negative 15 over 2. Add some number, subtract some number, minus 44. Did I type it in right? Yeah. Oil, 15 times 15 is 225 times 4. Oh, right here. The numerator is 49. The denominator is 4. That's what I did wrong. So this is still over 4. So this would be over the square root of 4, which puts this over 2, which changes these. Man, one little mistake and you get the wrong answer. You gotta love math. I was feeling confident too. I was on a roll. All right, so always be able to proofread your own work. So at this point, I now know u is 7 halves. Now I just plug it in. Negative 15 over 2 plus 7 over 2. Let's see. Now I'm second guessing myself on my math. That's got to be 8. 8 halves, which gives me 4. Let me go back to
plus 7 is 8.
Negative 15 plus 7.
Yeah.
Way to scare me like that. Because the next one is negative 15 over 2 minus 7 over 2, which would give me a negative 22. Yeah. Negative 22 over 2, which then gives me negative 11. Now, I'm going to go to my table. Negative, negative, 15 bigger than 7. So I have my answers at negative 4, Perfect. And negative 11. Perfect. So x does in fact equal negative 4 and negative 11. Right there. Gotta love when you make mistakes. I'm human too. Can't believe I forgot that step. That's so what my students do. That's so what my students do, and I tell them don't do it. To pay attention. And I just sit there and don't listen to my own advice. That's frustrating. Man, when I turned the board on, I had to deep clean the board. It was so smudgy and dirty. Has anybody got any questions for me, or I'm just going to pick another random Algebra 2 problem and solve it? Yeah, I'm going to do, yeah, that's what my plan was, is to do another example but when A is not 1. Because that's way more complicated. It does be like that all the time. If you're one of my students, you know I make mistakes on the board all the time like that. And I'll be like, Mr. Buzzer, where'd that number come from? I was like, oh, my bad. Because I'm just thinking ahead. I'm thinking of other things. All right. So let's dive in. I'm going to do a harder one. So I'm going to do day 6, number 4 off the Algebra 2 packet just because I can. That problem is going to be, let me just slide over so I have room to write. Let's see. I've got 8x squared. Oh, you want to see completing the square, Jay? Cool. I'll do completing the square on this one. Yeah, why not? Let's roll with it. 8x squared minus 9x equals x minus 3. So you want to see complete the square on this. All right. So completing the square is actually how the quadratic formula is actually derived. The quadratic formula that everybody's familiar with is actually just the end product of solving the quadratic abstractly. So that formula that everybody knows, the negative b plus or minus the square root of b squared minus 4ac all over 2a, is really the completing the square, the process. But now let's do it with numbers instead of letters. So the first thing I want to do when I solve a quadratic anytime is that you need to get it set equal to 0. So I don't have a 0 here, so I'm going to move these over. I'm going to subtract x, add 3 to both sides. This gives me 8x squared minus 10x, and then plus 3 equals 0. This is going to be beautiful. You have no idea. I'm already thinking steps ahead. Yeah, I know y'all's, I'm on like a 30-second delay here too. So I know y'all's stuff's kind of coming in slow as well. It's the nature of the beast. Well, I gotta move my tape down. I gotta move it down. Okay. All right. So when I want to do this to complete the squares, I'm going to move the minus 3 over. So I'm going to have 8x squared minus 10x equals negative 3. What I'm going to do is I'm going to try to create a perfect square trinomial on this one. But really the best way to do it is I need to have the number in front of x squared as a 1. So I need to be a little creative. So I'm going to factor out this number 8 from just this side. So I'm going to take 8 out of 8x squared, and that leaves me x squared. But then I'm going to take an 8 out of this negative 10. So that's going to give me, let's see, they both have a 2 in common. So I can take 5, so it'll be 5 halves. 5 halves x. And then I'm going to add some random number right here to it to make a perfect square trinomial, and that's going to equal negative 3. Now the rules of algebra state, whatever I add to this side, I have to add to this side. So I have to be careful because I'm 8 times this box. So I'm going to do 8 times this box. So I need to figure out a number for this box. Once I figure out the number for the box, I'm home free. All right, so let me change colors here to show you how to actually do the complete the square. What we're going to do is we're going to take half of my b. So we're going to do b divided by 2. Well, my b is -5/2, and I'm going to divide it by 2. I write it like this so it doesn't freak people out that I put a fraction on top of a fraction and whatever. Our rules to when we divide by fractions is we're going to change division to multiplication and take the reciprocal, which gives me -5/2 times 1 over 2, which just simply gives me -5 over 4. There we go. So I want to kind of put a box around this. Well, let's not use a box because I already used a box. So that gives me the -5 over 4, because when we multiply, these go straight across. Now I'm going to actually square this, and that's going to equal my box number. So I'm going to get 25 over 16. So right here, I'm going to put 25 over 16, 25 over 16. Now, the reason why I was going to put a box around this number right here, because that is actually the number that this is going to factor down to. So this should just factor down to 8 times x minus 5/4, because -5/4 squared, because -5/4 times -5/4 is 25/16, and -5/4 plus a -5/4 gives me a -10/4, which reduces down to -5/2. And that's going to equal my -3 plus 8 times the 25 over 16. Well, 8 goes into 16 2 times. So I can simplify that down. And now I have 8 times x minus 5 over 4 squared equals -3 plus 25/2. Add my fractions over here. So this will be -6 to create a denominator. So just kind of a side note here. I'm doing -6 over 2. That's going to give me 19. Yeah, 19 over 2. So now I have 8 times x minus 5/4 squared equals 19/2. I am now going to divide everything by 8, and I'm going to get x minus 5/4 squared equals 19, and 8 times 2 gives me 16. And then from there, I want to take the square root of everything. Remember to do the plus or minus in front of the square root. I have x minus 5 over 4 equals the square root of 19 plus or minus, and then the square root of 16 is 4. I'm going to simply add to get x by itself, and I have x equals 5 plus or minus the square root of 19 over 4. There's my answer. Easy peasy lemon squeezy. Now, what's really nice is with the quadratic formula, you could have just jumped right to this. Really could have just jumped right to this by plugging A, B, and C right in and not go through this whole process. But that was fun. Thanks.
Wait, why don't you do this? Well, you gotta move it down. The same problem to do the never mind. Then you can just show that.
Oh, show it with the
Dr. Loes method. Same problem.
Huh.
No.
I can. It's way more complex.
Okay, then never mind.
Yeah, Dr. Loes' method would end up being more complex, and for high school kids to try to understand it.
Nothing.
Although it's absolutely beautiful math. It's beautiful math, but it'd be more complex, and there's some rules that they'd have to understand to pull it off. So I really think like Dr. Loes' method at the high school level or junior high level is personally, whenever A is 1 and the B is an even number, so they don't even have to mess with fractions. Because in that case, that scenario, those are super easy. Super, super easy. As y'all can see, Coda is so riveted about math, he is just knocked out over there. He enjoys math so much it puts him to sleep. Like, feels like sometimes half of my students.
I mean, I fell asleep in your classroom, so.
You did fall asleep and I yelled at you for it. Didn't even realize I yelled at you. It was just a reflex. I want to give them a couple of minutes to respond back to see if they have any of their own questions before I pick another problem just to randomly work. Oh, I can do this one. I had a kid ask me a question about this one yesterday. Huh? It didn't show up on my chat. I wonder why it showed up on my chat. Does any of y'all got any questions or anything else? Or I'm just going to dive into a problem that somebody asked me last night. That's a domain and range question.
Sorry.
Well, he is mad, isn't he? You woke him up. Oh, big yawn. All right, I'm going to start. Did somebody ask a question? Oh, what?
Homestuck is my good, yeah, because about Dr. Loes' method.
Is the stream laggy? I mean, I know there's a 30-second delay here, but when you're watching it over there, reading the comments, it's fine. It's just behind.
Sometimes you have to, like, the first day you did it, I had to, like, close it out and then.
Gotcha. So.
Just close the window.
Show Dr. Loes' method with A not being 1.
It says with the 1.
Oh, like the easy version of it. Okay. Let me make a problem real quick then, because none of these problems that I have will actually fit that. So give me a second. Let me make a problem. Well, I don't have a pen right here. It's not my desk at school where I have a bazillion pens.
You're gonna walk away for a second.
All right, I'll be right back.
I was like, don't use her
Oh, I looked at it for a second. She would kill me.
On the shelf next to the turtle tank.
On the shelf next to the turtle tank.
Not the top, the middle shelf.
Ah. Okay. Like my string over my, it's weird that my chat's not even. It's not even refreshing. Oh, now it refreshed.
So to clarify, you said when A is a 1, it's simple. But when A is a number other than 1, then it gets more.
Absolutely.
Okay.
Absolutely. I'm going to show you probably the simplest form, and this is the one that I would really say, if you see this scenario, I would use Dr. Loes' method, because it goes from being a complex problem where you have to try to memorize formulas and all that to actually being able to solve it in like 3 steps. So let me make a problem real fast. So let's do x plus 9, odd plus an odd. What's the rule? There we go. Nope, that's a 1.
I wish your sister would come in here.
All right, guys. So let me show you what I'm talking about. This is a very simple problem, and yes, I know if you're in my Algebra 2 class, you should be able to factor this like this and get the answer. And factoring is always the way to go. However, if you struggle with solving quadratics or struggle with factoring, this method, if you see these scenarios, is very simple to do. All right, so we have the problem: x squared minus 12x plus 36 equals 0. So if you have a teacher that asks you to find the x-intercepts, the zeros or the roots, which all mean the same thing, you're going to just simply solve for x. That's all you're going to do. Now, this is a perfect square trinomial, which is a special factor, all types of different things. You do the AC method and all that. But the Dr. Loes method, and this is the scenario I'm talking about, my leading coefficient, the number in front of x here, is the number 1. And my middle term here, regardless of the sign, is an even number. If those two scenarios exist, you can use Dr. Loes' method very quickly to find the answer. So, same thing. I'm going to do my sum. My sum is negative b, so I have a negative 12 for b, so my sum is going to be 12. My product is my c, which is going to be 36. Then we're going to do half of my sum, so 6 plus some random number, and 6, that is not a 6. I couldn't tell you how many times in the day I do that because I'm thinking ahead. And 6 minus some random number is going to equal my product of 36. All right, from here, we just simply FOIL this out. Let's see. So I've got 36 minus u squared equals 36. Something's wrong again. X squared negative 12 is my product, is my sum. Take half of that, 6 and 6, 36, minus u squared. My product is 36. Should be x minus 6 and x minus 6. This should factor to x minus 6 squared equals 0. So x is supposed to equal 6. That's what it's supposed to do. Now the question is, did I set it up right? X squared minus 12x plus 36. So do the sum. Take half of the sum. 6 times 6 is 36 minus u squared equals my product of 36. When I it's right.
It's 72, James.
No, it's right. I'm sitting there because it's still new to me. I can't see the steps ahead like I see here. Like I already knew the steps. I could see the answer as soon as I look at it. Here I can't see the answer right away because I haven't done it enough. It's right. Watch what happens. I'm sitting there thinking, oh, my u's got to be a number. How's this going to work? I have to plug a number back in. I'm going to get 0, but I'm stupid. Watch. Subtract 36 from both sides. I got negative u squared equals 0, which is what I was seeing, and that's why I paused. That means u has to be 0 because 0 squared times a negative is just 0. Take the u, plug it back in. I have 6 plus 0, which equals 6. And I have 6 minus 0, which equals 6. So my answer here is x equals 6. Trust his method. I didn't trust the method. It's exciting. I love this because it's brand new, and you just don't see brand new math that the masses could kind of understand. All the new math is so far out there that I even barely understand it. But you see how simple this can be? I mean, really, with this middle number, you're not dealing with any fractions. If this is an odd number, you're always going to have over 2. But they can change it to a decimal and and deal with decimals instead of fractions. But I think decimals are the end of the world. So that's that. This is much easier. To me, the junior high kids, there's no reason why junior high kids can't do this. Just, if they have this scenario, they do this. If they have this scenario, you do this. Who? I didn't make a mistake.
Sorry, not trusting the method.
Not trusting the method was my mistake.
What about the complex version?
Okay, cool. Let's do the complex version. However, I don't want to listen to y'all cry when I'm doing this.
Okay, if you need to give yourself more room on the board.
All right, I'm gonna slide over. Let's do this. I need more room to do the complex method here. So let's do this. So let me find a nice pretty one here. So we're going to do 9x squared minus 10x equals 16. Okay. All right, let me take a deep breath, warm up. Y'all ready? Let's do this. Get it set equal to 0. 9x squared minus 10x minus 16 equals 0. What?
If you're just going to move it back over to do the method, why even?
I'm not going to move it back over to do the method.
Oh, okay.
Has to get it set equal to 0.
Okay.
All right. Now, in Dr. Loes' method, his method is predicated on this number being the number 1. So, what you're supposed to do is divide the entire thing by your leading coefficient. And that's going to give me x squared minus 10 over 9x minus 16 over 9 equals 0. I just reduced the entire equation. I scaled the equation by 1/9. If you want to think of it in terms of the actual math, what I did is I multiplied this whole equation by 1/9. All right, now from here, same rules apply. I'm going to do my sum. My sum is going to be negative b, so my sum is going to be 10/9. And my product is just simply my c, which is negative 16/9. That's easy enough. It's just fractions, no big deal. Learned that back in middle school. All right, the setup's the same. I'm going to take half of the sum. Well, if I divide 10/9 by half, I'm going to get 10 over 18. I'm just going to leave it like that. I'm not going to reduce the fraction. I don't care. Plus some number, and then 10 over 18 minus some number is going to have to equal my negative 16/9. Same exact process, but now if you notice, these look much uglier because of fractions. That's why I say it's much more complex, is simply because in my experience, most people suck at fractions. Just is what it is. All right, so I'm going to have to FOIL this out, and I'm going to have 100 over 18 squared, being lazy, minus u squared equals a negative 16/9. I'm going to have to multiply that 18 squared. Bring it over. I'm going to have negative u squared equals negative 16 over 9 minus 100 over 18 squared. Golly. 324. That's nice. And to get a common denominator, I don't think, does 9 go into 324 off the top of my head? Oh, it does. Nice. So we'll create a common denominator. I'm going to multiply this fraction by 36 over 36. You hear in my class, whenever you introduce something to an equation, you're only allowed to add 0 or multiply by 1. So I'm going to multiply by the number 1, and I'm going to get negative u squared equals, and here I'm going to multiply by 1. I'm going to do 36 divided by 36, that's 1, times my negative 16 over 9 minus 100 over 324. All right, 36 times 9 is 324. I get my common denominator. So I've got negative u squared equals, let's see, 16 times 36 is 576. That's a negative. I don't want to drop my sign and have a mistake and go crazy again. Over 324. minus 100 over 324. So I've got negative u squared. Now I just simply simplify. This gives me negative 676 over 324. Divide everything by a negative. I'm down to u squared equals 676 over 324. Good times. I may still run out of room. Take the square root of it. U is going to give me plus or minus the square root of 676 over the square root of 324. Fingers crossed these are perfect squares because I'm not thinking right now. Hey, it is. The bottom is. That's going to make my life easier. And then, perfect. This actually ends up being U, ends up being the square root of 676 is 26. I should really probably memorize these, huh? 26. And the square root of 324 is 18. Let me reduce my fraction to make my life easier. They both definitely have a 2 in it, so that becomes 13 over 9. And now all I do is plug it back in. Oh, I'm not going to reduce it. Don't reduce it. 26 over 18. The reason why, when I come back over and look, I already have 18 in the denominator. I already have a common denominator. So reducing it actually would have adds more math. So don't reduce it. Kind of think like a chess player. So to get my answers, all I do is plug it back in. 10 over 18 plus 26 over 18. This gives me 36 over 18, which is 2. Beautiful. And I have 10 over 18 minus 26 over 18, which gives me 16 over 18, which then we can reduce this fraction to 8/9. So x equals 2 and 8/9. Negative 8/9. I just got a text. I bet it's one of somebody saying I made a mistake. Oh, it's gotten white. All right, so let me check it.
It gets a bit confusing when we mistake.
Well, that's life. Everybody makes mistakes. Warms my heart that you've been crying. And mood. Still mood. Let's see. 2 is a solution, and negative 8 divided by 9 is a solution. Yep, both of those, that's the solution. So really, I've shown you all 3 different scenarios with Dr. Loes' method. There's an easier way I showed y'all to do this in class. We don't have to mess with fractions. But this is the method that he wrote the proof on, where you get a to be 1 and then just kind of go from there. It's not terribly bad. I mean, it's beautiful math. Not bad. No, I was reading the chat.
Oh.
I totally know I'm a narcissist and I want to watch myself, but come on. I was actually reading the chat because I can't see it over there. It's too small, and I couldn't figure out on YouTube how to make the chat bigger on my stream so people can actually read the chat along on the replay with it being so small. I tried to do what the YouTube channel said, but it doesn't work. So if any of y'all know how to make my chat larger, put it in the comments so I can try to figure it out so everybody can read. So everybody can read it. Wow, I got that one spot that doesn't want to come off.
I've cried if it was incorrect.
Nah, just I would sit there, and what I would actually do if it's wrong is I want to sit there and go line by line through my work until I figure it out. And I would spend literally the next hour, hour and a half going line by line until I figure it out to get it right.
And so I said, to be honest, fractions make factoring really hard.
They really do, to be honest with you. That's why there's a thing in math called scaling the equation where you can eliminate fractions altogether. If I haven't shown it to you guys yet, I'm pretty sure I have. or I can actually show how to eliminate fractions. We've got about 9 more minutes, and we'll call it quits, and I'll be back up at 5 o'clock. If you need to see how to scale an equation to eliminate fractions so you never have to deal with fractions again, I can show you that as well. That's every scenario for Dr. Loes' method. All right. So I think I'm going to call it quits here. Be back up at 5 o'clock. I'm going to stop the stream. I'm going to do some work that I have to do for school, get it sent over. What's up? Is that what they said? Yeah. Do it. Peer pressure. Wow, peer pressure. I know all too much about peer pressure. All right, so I'm just going to randomly make something up. Just kind of show you how to eliminate it. I don't know if this is going to have a real answer or not. I'm just going to randomly pick numbers. So let's do 1/3 x squared plus 2/7 x minus 1/9 equals 0. All right, I want to solve that. Now, if I was going to solve that, just when I look at it, I'm like, ugh. Even I'm like, ugh, fractions. I don't want to mess with it. I would just jump right to the quadratic formula. But since I'm talking about scaling the equation, I'm going to show you how to scale the equation. I'm going to look at my denominators. I have a 3, a 7, and a 9. And I'm like, what number can I multiply by to get rid of a 3, a divide by 3, a divide by 7, divide by 9? I need to figure out a number that is divisible by 3, 7, and 9 and multiply the entire equation by it. Well, that's easy enough. All I do is multiply the numbers. So I'm going to do 3 times 7 times 9. This gives me 21 times 9. This is a 9, 189. So I'm going to multiply my entire equation by 189. So I am now going to multiply this whole thing by 189. Now, from here, I do hippity-hoppity distributive property. But what you have to understand, it also goes across the equal sign there. So 189 divided by 3 is 63, which is conveniently 9 times 7. So I have 63 x squared plus, so the next one, what is 189 divided by 7? Well, that's going to be 3 times 9, which is going to be 27. And then what is 189 divided by 9, which is going to be 3 times 7, which is 21 equals 0. Now, I'm going to just jump to Dr. Loes' method, but I'm going to kind of do a sneaky little trick. The one that I showed you in class, I'm not going to do his pure method. I'm actually going to do like a slightly modified version of it where you kind of understand. What's up?
Where does the 2 go above the 7?
Oh, moron. 27 times 2. That should be 54. Thank you. My wife saved me from another mistake. So that's 54. Because you have to multiply it by 2. So it's 189 divided by 7, which is 27 times 2, which is 54. All right. So from here, I'm going to do a little sneaky thing. I'm still going to do my sum. My sum is going to be 54. Negative 54 because it's negative b. But my product, I'm going to do something a little different. I'm going to do a times c, kind of like the AC method that I show how to factor. So I'm going to do 63 times negative 21. And that gives me negative 756. Okay. From here, I'm going to have to remind myself I did multiply by 63. I need to remind myself that, because if I don't, I'm going to get the answer wrong. All right, same setup. I'm going to do half of the sum. So that's what, 27? Yeah, because I had to multiply it by 2. So I'm going to do negative 27 plus some number, negative 27 minus some number equals my a times c, the product, which is negative 756. From here, we just FOIL. It gives me 729 minus u squared equals negative 756. Subtract 729 from 7. So I have negative 756 minus 729. This gives me negative u squared equals a negative 1485, 1485. Get rid of your negative. U squared equals 1485. From here, I am going to go ahead and take the square root of it. So I have u equals plus or minus the square root of 1485. All right, and then from there, I just plug everything back in. But this product here, we multiply by 63. We need to divide it by 63. And then from there, you just plug it back in and finish off the process. So you still have to deal with a little bit of fractions to finish solving this off. Right off the bat, I would have just jumped right to quadratic formula and just plug it in. But this is the idea of scaling the equation, and then I just kind of continued on with doing Dr. Loes' method. You can see the answer is going to get a little ugly. At least it's two real answers, so that's a positive. All right, guys, I'm going to go ahead and shut down the stream. I'll be back up at 5. If you guys run into any other math problems or you just want to sit here and watch me do math, cool beans. I don't really care because I'm bored. I'm going to sign off, check my emails, do some school stuff, and then I'll be back up.